literally, I've looked at the Math Workshop test. It's 85% factoring. The other 15% is simplifying radicals. Which makes sense. We've done like 1,000 factoring ones. And I still have somebody in zero period this morning who cannot factor. I don't understand what's going on. Yes, dear. It's not you. You can factor. We've been doing them like 1,000 years. Oh, Jesus, bless your heart. You did it now, number one. We've done it so many times. Bless your little heart. That makes me want to cry for you. But I can't. I digress. Okay. Whew. If you don't like factoring. Whew. Okay, moving on. We have to figure out today how to complete the square. She doesn't care. She just wants to be on my nerves.
Ms. Thompson?
Yes, ma'am.
Can I have Faith Loreno to the main office, please?
Yes, ma'am. No, but I will. So we're going to do this math workshop even though we've not talked about this topic, but we're really smart. So if you're looking, it says Alonzo and Ada are both solving a problem. What line number do they go different on? Yeah. What line number does, like they start off the same. What line number do they go different on? Table 1 can have an extra point. They said it first. So we've got to decide on line 3. Even though we don't know what they're doing yet, we haven't done completing the square. That's what we're about to talk about today. Even though we don't know what they're doing yet, we need to figure out who we think mathematically was right on line 3. Do we think Alonzo or Ada was mathematically correct on line 3? Who was mathematically correct?
On the first one, on the left.
And why would you think Alonzo? If you think
They added 6 to, no, she's wrong.
So Alonzo added 16, Ada added 16. I do see a difference though on that right-hand side. I mean on that left-hand side. Are they both right? They both got different answers. I'm telling you, one of them's right. Why is Alonzo right? So does Ada. That doesn't mathematically help us.
I think it's Ada.
Okay, I'm just gonna go home and cry and I'll tell you the answer. It's Alonzo because mathematically, you know, if we do something to one side of the equation, we have to do it to the other. Ada added 16 to the left side. All of a sudden, out of nowhere, she added 16. And she didn't add it to the right side. What we do to one side, we must do to the other. We've been doing that for years. If I subtract 4 from one side, I subtract 4 from the other. And we normally don't add things, like I would add extra numbers, but today we are. So Alonzo is correct, and even though we don't know what they were necessarily doing, he did mathematically add something to both sides. Okay, number 18, really weird. They said solve by graphing, without technology. And then solve algebraically. Well, I'm going to go in reverse order. If I solve algebraically, so I've got negative 2x plus 2 equals 3x minus 3. I could add 2x to both sides, but again, we add it to both sides. We don't do it just to one side the way Ada was trying to. So we'll have 2 equals 5x minus 3. We add 3 again to both sides. We have 5 equals 5x. So we've got x equals 1. So we think the answer is 1. But they asked us to do it by graphing as well. So what we're going to do is we're going to graph the two lines. We're going to graph y equals negative 2x plus 2. And we're going to graph y equals 3x minus 3. And where should they cross? 3 can have an extra point. They better cross at 1. If they don't cross at 1, we've done something wrong, because we just said over here the solution was 1, which back to when we were doing systems, that meant they crossed at 1. So these lines better cross at 1. So negative 2x plus 2. I go up to 2, put my intercept, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, up 2, left 1, up 2, left 1. So I've graphed this one. I still got to graph 3x minus 3. I go down to negative 3. My slope is 3, so up 3. 1, 2, 3 over 1. Up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. So I've graphed y equals 3x minus 3. So I've graphed both my lines. Let me connect my dots. Now this is a roundabout way to getting to the answer that you and I both know is 1. But notice our two lines do actually cross on that x-axis at 1. They crossed at 1. That's why this was the answer. They crossed at 1, 0. So no wonder x is 1. Okay, now for the new packet. All the words. I'll leave that there for a second. I still got people writing. We've been working on, well, factoring for forever. We've been working on factoring, or we talked about using complex numbers to solve a problem. And today we're just going to find out a new way to solve a quadratic. And then tomorrow we're going to find out a final way to solve a quadratic. So basically, there's no reason Hal would ever give up if he sees the problem x squared plus something. He's got like a myriad of ways he can solve it. Now, sadly, on the test, if it says solve by completing the square, you have to solve by completing the square. But in real life, if Hal hates completing the square, because I'm not going to lie, quadratic formula is my favorite. If I get to pick how I'm doing it, I quadratic formula every time. So in real life, you'll get to pick your own way. But in math class, as always is, you need to make sure you understand each concept, so there will be problems that say specifically solve by completing the square. We are going to take a quiz on completing the square in quadratics before Thanksgiving occurs. Okay, so how to complete the square. What is the square? When we talk about factoring and we hear the word square, what do we think of? Like if you had, I think of perfect squares. So when they say complete the square, I'm thinking of perfect squares. And I like the square root in the second power, as long as no one said they were thinking square like the box. We're going to, we were at least doing math. Okay, so if you've got your calculator, we're going to use it today to help us out a little bit. So I'm going to explain it with number 1, and then after that, seriously, we're going to rely on the calculator to save the day. But I'm going to explain it with number 1, and to be honest, I don't use my calculator. I think it through. Okay, so what we're wanting to do today is, what if we were to move the 11 over, and we had x squared plus 10x equals 11. And we said we want to complete the square. So what we're thinking is, if only there was a number I could add on this left-hand side. And if I could just add this, whatever this beautiful number is, maybe I'll end up having a pretty factored thing. But, as is math class, if we're going to add this, whatever this number we come up with is, to the left side, we've got to add it to the right side because that's only fair. So we want a number to make this a perfect square. We want it to be like x plus 3 squared, x plus 5 squared, perfect here. So what number could we add right here to make this a pretty x plus something squared? It's really the question of the day. So you see there's a 10, and if you knew you wanted it to be like x plus 5 squared, for instance, what number would I need to add to both sides? If you FOILed it back out, what number would be missing on the line above? So if you FOIL back out x squared plus 5x plus 5x plus the last thing, what would the last thing be? So x plus 5, x plus 5. If I FOILed that out, I would have x squared plus 5x plus 5x plus what number? 6 can have an extra point. And so can 4. When I combine those like terms, I would have x squared plus 10x plus 25. Lo and behold, if only that blue line had a 25, life would be beautiful. And since we are the people creating the problem and the people solving it, we do get to add that 25 to both sides. Now, this is great when the middle term is an even number like 10, because 10 is divisible by 2. Notice 10 divided by 2 is 5. 5 squared is 25. That's why it worked out. So, for instance, if you're looking at number 3, I would think in my brain, 8 divided by 2 is 4. 4 squared is 16. I'm probably adding 16 to both sides. But most of us are like, whoa, Miss Compton. A little bit overwhelming here on a Wednesday, which I understand. So let's talk about ways we can get this 25, or ways we can get this third number every time without having to overthink it. Okay, so what we're going to do is we always put it where it's like x squared plus 10x plus some number. But how we figure out that number is we use this middle term, the 10x. So I'm going to call that the middle. Now you'll have to set it up where the something x is, and I'm calling it the middle. But we're going to take that middle number, all using our calculator. We're going to divide it by 2, and then we're going to square it. Every single time, middle divided by 2 squared. Again, our middle number was 10. 10 divided by 2 is 5. 5 squared is 25. But I don't even have to think that through my brain. Sadly. Well, I mean, I guess not sadly. What's cool is I got my darn graphing calculator. So I could say 10 divided by 2 squared. Or I could do it all in one step. Let me get it to zoom in. I could do it all in one step. I could say 10 divided by 2 squared. I put 22. 10 divided by 2. 10 divided by 2. Come on, Miss Compton. 10 divided by 2. I can type today. Squared. And I still get 25. And again, if you are like Miss Brister and you love that fraction button, no one's holding you back from it. So she could press alpha y equals. Oh, good grief. Alpha y equals. Does this one not work like that?
Yeah.
Darn you, non-yellow. God bless you, black calculator people. I like my yellow one. I could press alpha y equals, tell it I want a fraction, 10 divided by 2, and then square that whole thing as well. And I still get 25. I normally don't press the fraction button. I feel like it slows me down, for being honest. Instead, I just put it in parentheses. So I do 10, division symbol 2, and then squared. I feel like it slows me down because I'm trying to be fast, and pressing that extra button slows me down, so I don't bother. Okay, so again, we found that magic number, the number that I put the squiggle marks under, simply by taking the middle, dividing by 2, and squaring. Okay, so, and you're like, why would we do this? Well, let's continue. We're actually going to solve this. On the left, it did end up being a pretty factoring thing. Hence the term completing the square. We did complete the square on the left. On the right, we have to add 11 plus 25. Well, that adds to 36. We still need to get x by itself. So we're going to take the square root of both sides. So I'm going to have x plus 5 equals plus or minus that square root of 36. Again, just a reminder, with quadratics, they don't have to have 2 answers. We normally are anticipating 2 answers, hence the plus minus. I know the square root of 36. It's 6. So I have x plus 5 equals plus or minus 6. Yes, dear? So since I took the square root of both sides, the square root, the house, and the square canceled out. Okay, but I can still reach a solid answer. If I break this up into 2, I can have x plus 5 equals positive 6. X plus 5 equals negative 6. So I end up getting x equals 1, and I also end up getting x equals negative 11. And literally, those are my 2 answers. So if we were to graph it, the 2 spots where our graph crosses the x-axis are 1 and negative 11. Now, completing the square is not, it's not for wins. Would I check myself with my calculator and make sure those are the two spots where my graph crosses? Heck yes, I would. Heck yes, I would.
Is it a 1?
It is a 1. Okay, are there any major questions about number 1? I swear we just have to do a couple more, and eventually the process starts to, you're like, okay, this is the same pattern every time, I can do this. Okay, we're going to skip number 2 and go to number 3. For an extra point, can you tell me why we're skipping number 2 at the moment?
Because we just don't like to.
We're going to come back to it, but why are we mad? Why is 2 different from 1 and 3? I'll give you a hint. I'm looking at that middle term.
Oh, it's this.
Because it's odd, 5 can have an extra point. That odd number is going to be a pain in the rear, so we're going to go to the next even one. So let's go to 3. So it used to be, I'm going to go ahead and move that 85 over. It used to be x squared minus 8x, and I'm going to put equals 65. I'm going to move that 65 over. We don't need him. He's not going to help us complete the square. We need to figure out what number is going to help us handle this. And yes, and again, all I'm doing is middle number, which is negative 8, middle divided by 2 squared. So if I take negative 8 divided by 2 and then square it, I get 16. Middle divided by 2 squared. So apparently, the missing number is 16. And every single time, it's middle divided by 2 squared. So if only I had a 16 that I could add to both sides. Then on this left side, I would have x minus 4 squared. Now notice it always ends up being half of the middle term. And if you start questioning yourself, you can always do what we did on number 1 and FOIL it back out to make sure you're not crazy. But no, x squared minus 8x plus 16, that does work out. What's 65 plus 16? Now, it doesn't always have to be a pretty number like this. I'm calling 1 and 3 the easies because they end up being such pretty numbers. It's not that the process is easy, it's just that the numbers end up being easy. Okay, so I want to get rid of that squared. So I take the square root of both sides. And I have x minus 4 equals plus or minus the square root of 81, but I know the square root of 81. What's the square root of 81? 9. Perfect.
What language is that?
The plus or minus. So I'm going to say, you don't even have to put that because I'm going to do both cases. X minus 4 equals the positive 9. X minus 4 equals the negative 9. As long as you keep in mind there's the positive and the negative version, you're good to go. So on this one, 9 plus 4 is 13. On this one, negative 9 plus 4 is negative 5.
We're done after that?
We're done. And again, if I were to go back to the beginning, graph on my calculator, x squared minus 8x minus 65, and check where those 2 zeros are, where it's crossing the x-axis, it would be these 2 numbers. So basically, we're manipulating the problem to make factoring happen. You never thought in your life you would want to factor, but it turns out if you can make it go, life works out really nicely. Okay, I'm going to say number 6 is yours. That I'm going to say is part of your homework, but honestly, you could go ahead and get it done really fast. It's still on the easy to me, meaning that it still has, ooh, that's a lie, I need to do 6. There's a reason I worked these out. Never mind. It was not 6 that is your homework. That is a lie. That's why 7 went ooh.
It's 5.
No, it is not 6. And so I thought 6 was an easy, and we're about to find out why it's not an easy. It's more of a medium. Why did I think 6 was going to be an easy? Because of that 8 in the middle, right? I thought 8 divided by 2, that's 4. 4 squared 16. Like, this is going to be nice. Real nice. So I started off, I said x squared plus 8x plus some number equals negative 22 plus some number. I just need to figure out what that number is. And it's 16, because again in my calculator I said middle divided by 2 squared. So 8 divided by 2 squared is 16. And so, on the left side, I had what? I'll give you an extra point. Uh, 1, 3, and 5, and then 4. I don't know about you. Okay, 135. 136, sorry, 5. Whew.
You skipped it.
I didn't say nothing. Okay, but the problem is what happens on the right. What number do I end up with on the right? That's the problem, that -6. Okay, so you're like, I don't understand. Well, if we take the square root of both sides, we've got x plus 4. I don't know why I put parentheses. We've got x plus 4 equals plus or minus the square root of -6. We just took a test on how to deal with these negatives under the radical. What should I change that right-hand side to? It's plus or minus square root of 6, and then I add something else. What do I add? If you said I, you can add a point.
I said
Abby for sure did. So literally, darn it, this one has complex roots. So what does that mean about its graph? Where did it cross the x-axis?
1. Just kidding.
What did we decide with complex numbers? That their graphs never cross the x-axis. So if Mia were to graph number 6, it should never cross the x-axis because that's the kind of solution she's getting. Okay, but we're still not done. I'm going to go ahead and move that 4 over. I'm literally going to leave my answer as -4 plus or minus square root of 6i. Again, and I've got like 4 of you in here who forgot about the I part. If you thought you could just put I in your calculator and always get the answer, you're wrong. I would rather see your answer with I than that you've somehow decimalized the square root of -1 and give me some weirdo decimal. This is what I want, not a weirdo decimal. Now, if Gracie doesn't like the plus or minus, so if she wants to write her two answers as -4 plus square root of 6i and -4 minus the square root of 6i, no one's going to count off for that. The plus or minus is seriously just me and other math people being lazy. Okay. So these are the ones I'm considering along the easy. Now for what I'm going to call the medium. Let's go back to dreaded number 2. Number 2 looks nice, but darn that 13 for being not a an even number. So let's go back to number 2. I'm still going to use everything. I'm still going to say x squared minus 13x plus some number is going to equal -36 plus some number. And literally, I'm still going to use the same process. I'm going to take that middle, which is -13. I'm going to divide it by 2. And I'm still going to square it. So the way on, so it was x squared minus 13x plus something. And we're mad at it because of the 13. But again, the same process happens every time. It's still middle divided by 2 and then squared. So my middle was -13. So I did -13 divided by 2 and then squared. And I got a decimal, and I don't want a decimal. How do I change it to a fraction? 6 get another point. Math correct? Suddenly I've got an answer I can work with. Yes, I would rather see 169/4 than 42.25. In fact, I can promise you, when we finally wrap up the end of chapter 4, the test says on the top, no decimals. Because we don't want no decimals. We want fractions. Okay, so we found what the magic number was. We're just kind of mad because the magic number is not pretty. It's a terrible, terrible fraction, 169/4. I say it's terrible, but it ends up working nicely. Any guesses as to why it ends up being our friend? Tell me about the number 169. And 4 is also a perfect square, so it's going to end up working out nicely. So anytime I see perfect squares in numerator and denominator, I still don't have a panic attack. Okay, so literally, it's always the middle divided by 2. Well, on number 1, 10 divided by 2 is 5. On number 2, 8 divided by 2 is 4. On number 3. On number 2, 13 divided by 2, we're just going to write it as 13/2. That's all we can do. So again, to figure out that last number, we do middle divided by 2 and then squared. But if you're just trying to figure out what goes there, it's just middle divided by 2. Okay, but we run into an issue on the right of, oh no. So either you can be brave and get common denominators of 4, or you can be a wimp like me, and you can say, yes, your calculator knows what you just typed in. I don't know if you realize that, but my calculator knows that's what I was just working with. So if I say plus, it knows I mean 169 over 4, plus I need to add a negative 36. God bless you, calculator, for going ahead and doing math for me. The answer is 25 over 4 on the right. Again, when I worked it out, did I change negative 36 to negative 144 over 4 and combine my like things with the same numerator? Yeah, I did. But, same denominator. But if fractions are not your friends, and I'm telling you, you have to be friends with fractions, have no fear, the calculator can do it for you. Again, if you already have 169 over 4 on your screen, if you just say plus negative 36, your calculator knows, hey, add negative 36 to my fraction. And since you already liked fractions, it still gave you the answer as a fraction. And I'm still happy with the 25 over 4, because 25 is still a perfect square. So that's why I said this one was just a medium, because even though it's a pain with the fractions, it's still going to work out beautifully. Okay, so we get here. Are there any questions to this second line? Well, getting to the second line is the hardest part of this problem, because from here on out, it's same old, same old. I take the square root of both sides. Those cancel out. I've got x minus 13 over 2 equals plus or minus the square root of 25 over 4. But hey, I know what the square root of 25 over 4 is. It's going to be plus or minus 5 over 2. Agreed. 25, the square root is 5. 4, the square root is 2. So I literally just have x minus 13 equals plus or minus 5 over 2. Well, your answer is x equals 13 over 2 plus or minus 5 over 2. But you're not that lazy, are you? I hope not. Now, if you stop there, am I pretty proud you made it that far? Yes. Am I probably going to let it go? Maybe. But how much harder would it be to just say 13 over 2 plus 5 over 2? Well, that's 18 over 2, which is just 9. So one of my answers is 9. And the other option is 13 over 2 minus 5 over 2, which is x equals 8 over 2, which is just 4. So if you just persevered a little longer, you end up getting nice, pretty answers, 4 and 9. So if I graphed this weirdo function on my calculator, it would cross the x-axis at 4 and 9. I do. I know. You leave those alone and only mess with the numerators. But again, if you're still mad at fractions, you can say second square root. You can do all the math you just did in your calculator. So second square root, second answer. It's going to tell you 5 over 2. And then you could tell it plus 13 over 2. I mean, you can make your calculator do all the fraction stuff for you. Literally. You just have to be its friend. Okay. We're going to save number 4 and 5 for tomorrow. Look to the back. There are some that are yours. Notice on 4 and 5 we had a leading coefficient that's not 1. So what problems can you not do tonight on the back? You can't do 8 and 10. But I'm going to be so nice as to tell you what the answers are on the other two, so when you try them, you know whether or not you were on the right track. Number 7, I'm going to call it a darn medium because it involves fractions. But your two answers are 2 and negative 3. Number 9, I still consider an easy, even though it ends up involving complex numbers. It ends up involving I. My answer for it, my two answers are 3 plus or minus 4i. And then number 11 is definitely a medium. Maybe a medium plus. It requires a little perseverance. Because not only does it involve fractions, but it also involves imaginary numbers. So my answers are kind of stinky. I've got negative 3 plus or minus the square root of 15, I over 2. Or, if you'd rather, I've got negative 3 over 2 plus or minus square root of 15 over 2i. Either one is okay. Either one is okay. They both mean the same thing. One I made them a giant fraction. One I made them 2 separate fractions. They mean the same thing. Okay, be brave and try those 3. There will be a checkpoint at the end of class tomorrow. If you think I'm going to quiz you on something without a checkpoint, he's wrong. Yeah. Yeah, so it's not possible.